Hello everybody and welcome to another Unreal Engine tutorial. Today we are going to be looking at line tracing. Now I will be doing a blueprint version of this and the C++ in the second half to the video. So if you're only interested in the C++, then skip to the end for, skip to the chapter for that. But we're going to get started. This is fairly straightforward stuff. Now, let's have a look. We have our character here, our character blueprint, and let's just go and do this off the tick event. We shouldn't really be doing things off the tick event, but I'm going to be doing this anyway. And we can call line trace. Now we have loads of things by channel, multiple line traces and all sorts of things. For the time being, I'm going to do line trace by channel. Now we get this rather obscene node here with a lot of options and everything else. Start, that is the starting point from where we want to do our line trace, and end is how far we want to go, and our out result is exactly what it's hit first. Now if we did the multi, we would return an array of multiple items, but we don't need to worry about that for this first segment. Now you can do a line trace from pretty much anywhere, but if we're playing the game, generally we want to be doing this from what we're looking at, and the best way of doing that is to get the camera location, the center of the camera, and then line trace forward from that position. Now how do we do that? That is vector math. So what we can do here, we got our camera component here, we can do get world location. That is going to be our start, because this is our camera location. If we look at our camera here, it is bang smack in the middle of this item, and this is where we want the line trace to start, because we don't really want to start it behind the character. Well, I mean, maybe you do, but generally you want to be doing from what you look at, not what's behind you. And then from here, we need to get the forward vector and do to a point that is along that line, along that vector. So we have our location, we can do our get world rotation. From here, do get forward vector, and then that gives us our forward vector. We can then multiply this, and we convert this to a float. Single precision, let's just do 1000, and then we add this to our location, and then that is our end. Now what this has done is, if any of you know vector math, a vector is one that has a direction and a magnitude. So we have our location here, and we want to go forward 10, we need to get the direction, which is why we've got the rotation. We need to get its forward vector, so we need to get the vector that we have along this line. Usually it's a very minuscule difference from the world location, just to denote that it's going and pointing in that direction. And then we need to times that by 1000, so it then follows that line 1000 in-game units, and then we need to add that to our world position, because what we've got here would be a normalized vector that is just 1000, has a magnitude of 1000. It's not actually from this location. So we need to add it to this location to say, right, at this location, go 1000 units in this direction. And that's what we've sort of done here. And then that's why we've added it to this world location here. Now we've got the several trace channels. You can create your own trace channels. Camera, visibility. I tend to leave it at visibility, because really at the end of the day, you're going to be tracing stuff you can see. Complex, that makes it quite intensive. I tend to not bother with that. Actors to ignore, if you need to ignore specific actors. You can make an array here, make array, and then maybe add self if you've got it behind the character and you want to make sure you ignore this character, you can do that, and then that'll make sure that this never comes up in your thing. Then we've got our draw debug. We got for duration, persistent, and for 1 frame. For debugging purposes, I tend to go for 1 frame. If you want to see the path of your line trace for the duration, you can do that, but it gets a little bit hairy on the screen. You've got this ignore self flag, which is exactly the same as what I did with a make array. And then you've got trace color, draw time, that kind of thing. So if I now play, you can now see we've got this red dot. This is where the line trace, and this is where the thing has stopped. If I change that to for the duration, you can see now this is getting a bit hairy, but this is the part. You can create some nice things with this, but obviously it's debug only, so don't try and use that for production. Now, have we hit anything? This is this return value here. And that's basically saying, have we hit anything within that 1,000 range that we have? If we have, we can break this out. And then we get a humongous node here full of lovely goodness and information, like distance to what we've hit, you know, how far away the object is that we hit, the location, we've got our normal, what actor we've hit, if we have a procedurally generated instance spawner, we get the index of the item that we've hit, and then obviously the trace start, the time it's taken, whether we've overlapped, so and the location of the hit. So let's just print string here. And I'm going to get our actor, get object name. That'll do. So now we will be able to see what we are looking at. Static mesh 4, 37, 24, 44, 46, 34, 9, 0. So yeah, that is pretty much line trace. Now the difference between that and the multiple is if I hit this object, it stops at this object. If I was to be here and do multiple, it would hit this object and the one behind and the one behind, and it would then return all of them. That is the only difference. You might want to utilize that in some fashion, but be wary that the more you try and return back, the more complex it will be, and then that will mean the more load it has on your game. So yeah, that is that in a nutshell. So we are just going to briefly move over to the C++ side and just do the same thing. Okay, so what do we need for line trace in here? We are going to need a library for Kismet, Kismet system library, because we will need the that to do the actual line trace itself. We'll create a, do we want to create a function for this? Have we got tick in here? Yes. We have our camera in here, first person camera component, and we want an f vector start is this get component location. That was the one. They changed it ever so slightly. So now we've got that, we have our start. Now we need to get the our vector times 1,000. So we need to get our forward, which is going to be this, and there should be a handy get forward vector. And that just does the get rotation and then returns the forward vector. And our end for this is going to be our forward have I misspelled? It's just forward. There we are. Forward times 1,000, because that's what we did before. And then from here, we are going to add that to our start. So what do we need for the actual trace? A little bit more code, because obviously it was quite a big node, but what we need is an f hit result, and this is going to be our out hit. And this is the equivalent of our out hit here. This one here. That's what's getting returned there. So we also need what types of channels we want to allow. So T array, and we want T enum as byte, and this is going to be an E object type query. Bit of a mouthful, but trace object types. Ooh, trace object types, and then we want our trace object types dot add, and then we want our Unreal Engine types. I can type convert to object type E collision channel and ECC world static. Now you can have world dynamic and things, but you know, generally you'll be tracing, you know, items that don't move. You could probably add dynamic if you want to trace items that do move, but this simplifies the query as it is. We can also add our self to this as well. So we've got our T array a actor, which is a pointer, and then we have our ignore list, and then ignore dot add get owner. So we can do that, and then that just makes sure it ignores ourself. Now the actual trace itself, bool result. The bool result will be the equivalent of this return value, so whether it's successful or not. And then we need our Kismet system library. Line trace by single. And now you see you've got the same information here. Now the world refers to our map, but you can pretty much just put get world in here, and then that's all you need to do. We have our start, we have our end, we have our trace channel, which is our trace object types here. Complex, no, don't want it complex. We have our ignore list, ignore. Our draw debug, which will be E draw debug trace for one frame. We have our out hit, and then ignore self is true. Given that we already have this, what's going on here? I'm just going to put for our objects in here. Objects. There we go. Now we have this working with that because it's slightly different for the other one. But we have our thing if result, and then we have our out hit result. Our out hit dot actor get name. So if we want to see what that is, we can pretty much just add our on-screen debug message. Just print F. Right, now that's working. We can get rid of this, compile, save, and play. And we've got the same thing, but obviously in C++, which makes it a little cleaner and a little better. So again, if you're not doing a C++ project, you can ignore doing it this way. But if you are, this is how you would do line trace by channel. Pretty straightforward stuff. And this is also how you do your vector math for getting stuff. The other way of doing it is if you want to line trace what's between you and a specific actor, you can do actor location, and you can call what's called find look at rotation, and then you can get the target actor's location and it'll give you the rotation, and then you can get a forward vector from there. And then that allows you to do a line trace between you and somebody else or some other actor or something. But either way, that is going to be it for this episode. So thank you very much for joining, and I hope to see you next time, guys. Bye for now. Bye bye.